Welcome to this section of MatPlotLib for Python developers, diving into MatPlotLib. In this part, we are going to take a look at why plotting is a useful skill to learn, how to think about the art and science that is the known and unknown about plotting, how to set up and configure MatPlotLib, and the tools we'll be using in this part, and how to make a set of basic plots using MatPlotLib. The first part is understanding data dimensionality and why we plot. Most data is not small in dimension and importantly is not one-dimensional. In other words, when we are dealing with real quantities that we are trying to understand, we are not just dealing with single numbers, 1 or 2 or 3 extra. We are actually dealing with complex higher dimensional objects, vectors, tensors, matrices, where data is related to other sets of data, and these pairs of data points are ultimately what we are most interested in. So when it comes to visualizing this data, we actually have to keep in mind that we have a finite number of dimensions, a big variable to visualize things. We have, for example, the position, where the points lie within the screen. If you are lucky enough to have a 3D monitor, a virtual reality headset, you have 3 dimensions. For us, we are dealing with a 2-dimensional monitor. We really only have X and Y, horizontal and vertical. In other words, on the screen, our data points or our data curves or our shapes lie. We also have color and opacity. In other words, we can change the color of our data points to indicate some features of that data, some quality that the data has. Here, you can see we have an obvious trend in position, but also in color. And finally, when dealing with something like a scatter plot or other kinds of plots, we have shapes and patterns available for us. So we can not only change the position of data points on the screen, the color of how they are represented, but also if you are using individual markers, the shape of them. So here you can see we have 2 position ordinates, a color coordinate in a shape coordinate, giving us 4 dimensions visualized at once. Now, usually it's not good idea to use all 7 or so of these dimensions at the same time. You end up having a cluttered plot that doesn't really inform so much as obscure the features the data has. And really, what you are trying to do when visualizing data is to translate quantitative information, that is the numbers, into qualitative information patterns that your brain can intuitively interpret. So good plots all ultimately highlight qualities of the data. These qualities are properties of the entire data set, not just individual points. These are properties like the scale, that is how far these data points range, the density, where we find the shape, in other words, how the density changes based on where in the plot we are, as well as the modality or these data points clustered in one area or multiple areas. Choosing the correct types of plotting tools can be a big important thing in terms of whether or not your plot actually shows the qualities that the data has. Here you can see some set of data plotted with the 2 different choices, one on the left with a simple scatter plot, with one on the right showing the density of the points based on the color. The left-hand plot completely obscures the fact that our density is growing towards the inside. So really choosing the correct set of tools for the job can really mean the difference between a plot that tells the viewer nothing and a plot that tells the viewer everything that the data set is actually showing. So in this part, I'm going to begin by actually making a set of plots. Now let's look at how to make 3 simple types of plots, how to change the color lines and marker styles in these plots, and how to label some of these features in our plots. Let's dive right in. Note, beginning, we are going to import NumPy to deal with the arrays as well as MatPlotLib's plot module. Since we are lazy, let's import NumPy as NP and PyPlot as PLT. Since we are using the Jupyter notebook and I want these to show up nicely in our videos, we are going to run a few extra lines here as well. Let's begin now by building a set of simple data points. Now, using the NumPy array function, we can generate some values between 0 and 10, and with the plot method from PyPlot, we can actually plot these things. Let's plot x versus the sine of x, and you can see this gives you a really simple function call, two arguments, one for the x and one for the y values, and we get back a nice simple plot. Right from the get-go, we have got pretty sensible defaults. We can also label our x and y axis using the x label and y label method. We can give that a string. Let's call it something really simple, x-axis and y-axis. And as you can see, it'll throw down those x and y-axis. We can call plot multiple times, and it'll accurately generate multiple lines on our same figure for us here. Here you can see we are calling it once plotting x versus the sine of x, and then once calling x versus the cosine of x, and this won't generate two separate plots, but instead plot two different curves on the same set of axes. You can see it will automatically choose different colors, so we can tell the difference between these two curves. Now, what if we didn't want to just be able to tell the difference between these curves, but actually have them labeled? Well, we can pass this keyword argument called label that will actually give each of these separate curves a label attribute. Now, by default, that does nothing. See, nothing extra happens. But if we then call the legend method, we can actually get an automatically generated legend that uses those labels for each of those curves. We can also change the attributes of these curves, the visuals. For example, we can change the colors. So let's make the first one, rather than automatically blue, let's force it using the color keyword argument to be red. And here you can see we have a red and blue curve. It automatically sets the second curve to start in our loop of colors. So if we want it to be red and green, we would then force the first one to be red and the second one to be green using the color equals green keyword argument. We can also use short keywords for this. So for example, we can replace red with R and green with G. This works for red, green, blue, black, yellow, cyan, magenta. Now, the two that this is not obvious for her, blue and black, since they both start with blue, B, blue is B and black uses K. So if we want that second one to be black, we would use K. And if we wanted it to be blue, we would use B for blue. We can also change the style of these lines. So for example, we can add the keyword argument marker to actually put down a data point marker at each point in our array. So in other words, everywhere update a point occurs in our two arrays, it will throw down a visual marker. We can also change the style of the lines using the line style keyword argument. So right now, rather than using solid lines, we can use two dashes to produce a dashed line, and if you only want to have markers. So in other words, we want these dots but no lines. We can use the line style equals none, and that's the string none rather than the Python null object. Finally, we have a short, quick way of summarizing all of this using the format codes that MatPlotLib provides. So, by providing a third non-keyword argument, we can provide. Now, let's just do it with a single example color, a marker style. Let's do something we have not seen before in a line style. And here we get, and since this is a non-keyword argument, we of course have to make sure it goes before the keyword arguments. And what we get a red curve with plus signs for the markers and a dashed line between them. You can see here where quickly banging out plots, and if you want to get from point A to point B without too much typing, this is a really quick way of doing things. Generally though, if you are writing scripts that you want to be more self-documenting, I would recommend using those keyword arguments instead. Finally, you may not want to use the automatically chosen access limits MatPlotLib provides. You may instead want to zoom in on a certain region. So let's say we are only interested in positive values. So in other words, where the y-axis is greater than 0, we can use the ylim method to limit ourselves to looking at values between 0 and 1. In other words, the first argument is the minimum and the second one is the maximum. We can do the same for the x-axis as well, and here you can see we are now automatically looking at values between 0 and 1 on both the x and the y-axis. Let's look at another kind of plot now. Let's start by generating 1,000 random numbers using NumPy's random method, and let's generate a histogram of these random numbers. Now, histogram is a way of showing the probability distribution of these numbers, and since I've chosen a normal distribution, it should look like a standard classic bell curve, and you can see in fact what we get is a basic bell curve. Histograms are a quick and easy way of beating up your data without having to manually choose bins and automatically feed it into the kind of a bar graph. So you can look at the probability distribution of a set of numbers. Let's finish off by looking at a kind of plot that shows 3 different dimensions to it. So up until now, we have really only looked at 2 dimensions, x and y, and really a fourth, there a third dimension comes in our marker or line style. These have been very discrete so far to different values, that sort of thing. Let's look instead at a continuous 3-dimensional data set. So what we have generated here is a smooth Gaussian random field. These are commonly used in all kinds of applications. The most common that I have come across is in the study of the cosmic microwave background radiation, the initial blueprints of the Big Bang, which can be described as a Gaussian random field. So let's take a look at what this simulated cosmic microwave background radiation looks like. We are going to use a method here called show, and since this image has 2-dimensional positions from each point in the sky as well as third dimension indicating the density of brightness of each pixel, the concentration of matter in the cosmic microwave background, we are really dealing with 3 dimensions. IM shows an easy way of visualizing three-dimensional data. We have our vertical positions, our horizontal positions, and then a color each indicating different values. This color is indicated and labeled using this color bar method. You can see if I comment it out, I get the image without that nice little indicator. And I can also change the kinds of colors I use. So right now, by default, this version of MatPlotLib, the 1.x series, uses jet as its default color map using the CMap keyword argument. I can specify a different color map. Say, for example, the new default MatPlotLib color map in versions 2 and later, and there is of course a whole range of color maps. Simply look on the MatPlotLib documentation to see these different color maps. I happen to be a particular of Magma and Inferno. I think the transition from black to white is aesthetically pleasing to me. So in summary, for this section, we have gone over a little bit about how information is visualized, why it is important and useful to do that. We have also seen how to set up our MatPlotLib in Python environment. And finally, in today's video, we have seen how to make three simple kinds of plots and go quickly with just a handful of lines of code from numbers to qualitative visual information.